Hey guys, Mr. Cree back again. Just posted a video a couple minutes ago for the first geometry page. We are now on the second geometry page. Okay, looks like this right here. There are 8 problems. The first one had 9. Okay, this one has 8. Again, I'm only going to do 4 problems because I don't want to give you every single question, every single answer to all the problems here. So I'm going to show you some examples. I am going to be going over 1, 3, 5, and 6. Okay. Number 1. Tell whether the angles are adjacent or vertical. Then find the value of x. So it's a 2-part question. Okay. Again, guys, I want you guys actually trying this before you watch these videos. So please try this before you watch the video. That the way you actually are. That way we can actually maybe work on the honor system and feel like you are actually doing your work. Okay. All right. Number 1. Tell whether the angles are adjacent or vertical. Then find the value of x. Well, I have a 58-degree angle and then a 3x plus 2 degree angle. I don't know what that 3x plus 2 angle measurement is yet. We will find that out shortly. Okay, but I do know that they appear to be in side by side in a right angle. Okay, so we got a right angle here. They both share a line segment in this angle. They are side by side, and well, side-by-side angles are adjacent angles, so they are adjacent. Okay, second part, got to find the value of x. Now, in the last video, we done something just like this with supplementary angles. This time we have a complementary angle, and these two angles must add up to equal 90 degrees. So I have 58 plus 3x plus 2. And that is all going to be equal to 90 degrees. Okay. So this is a multi-step equation. With it being multi-step, we can't just go straight into solving it yet. We got to combine like terms first. Okay, so it looks like 58 and 2 are like terms as well as 90. Okay. I'm not dealing with 90 yet. I will deal with that in just a few moments because I have 2 parts to an equation, or 2 sides to an equation, and I want both of these sides to be balanced. Okay. So we also have 3x. 3x just by itself, so I'm just going to rewrite this down here as 3x. And it's going to be plus because 58 and 2 are both positive. You add 2 positive numbers together, you get a positive sum. 58 plus 2 is going to be 60. And that is going to be equal to 90 degrees. Now we have a 2-step equation. Okay, so you got to get 3x by itself. Okay, that's the goal. All right, in order to do that, I must get rid of this constant, the 60. Okay, remember 60 and 90 are like terms, so I'm going to get rid of 60 first. Okay, so on the left side, if I add 60, I need to get rid of it. In order to do that, I'm going to subtract 60. Not from one side, but both sides. I don't know why I done that. Let me do that again. Messed up there. There we go. All right. So we got 60. All right. 60 minus 60 is going to become 0. And that 3x is going to drop down below that. Okay, now I'm left with 3x equals 90 minus 60. 90 minus 60 is going to be 30. Okay, now I got to figure out what x is. Okay, so 3 is a coefficient, and 3 is being multiplied to x. Okay, so to undo all that, or to undo this property right here, this multiplication part right here between 3 and x, I'm going to divide both sides by 3. 3 minus 3 is going to simplify to 1, so I'm left with 1x equals 30 divided by 3, which happens to be 10. So the value of x, which is what it's asking, is 10. It's not asking for the angle value here. It's asking for the value of x. Okay, that's as far as you gotta go. So guess what? Number 1, just check it off. If you got that right, great. If not, I hope you guys may have found where you may have went wrong on that one. Okay, let's move on to number 3. This is a scale factor problem. This was in Unit 1. That was way back in August, September. So it's going to be a few minutes. It'll probably be a little bit, well, it may take you a minute or two before you figure this out. Okay. A snake at the zoo is 4 feet long. Oof, I don't like snakes. Those are just weird creatures. Okay. A snake at the zoo is 4 feet long. A scale model of the snake is 2 inches long. What is the scale factor? Okay. So what it's doing is comparing feet to inches. Scale factor wants, we can put it in terms of feet to inches, but scale factor wants us in the same unit of measure. So we got to get to inches. Okay. So we're comparing 4 feet. This is number 3, by the way. 4 feet to 2 inches. Okay, I put a colon there. I don't know why I just done that more than once there. Okay. So we got a colon there. So 4 feet 2 inches. Okay. So we want it down in its simplest form. In this case, we need to find an equivalent ratio for these two, for this right here. Okay. So what factors do 4 and 2 share? Okay. So I'm gonna put 4 here. I'm gonna put 2 right here. Okay. 4 and 2 share. So you divide 4 by, you get 2 and 2. Okay. You can divide 2 by 2 also, and you get 2 and 1. Well, this right here works. Okay. So the factor is going to be 2. All right. So I can divide 4 by 2, which is 2. So I'm left with 2 feet to 1 inch. Okay. This is my simplest form. Okay. Scale factor wants it in the same units of measure. So I got to convert feet into inches. Okay. So remember, 1 foot is equal to 12 inches. I'm not going to touch this. 1 inch is going to be in my final answer. Okay. So I got to make this 2 feet into inches, like we said. Well, I know if 1 foot is 12 inches, that means 2 feet is going to be 2 12-inch sections, which is going to be 24 inches. Now you can write it this way. This could be your answer here, or you could write it as 24 to 1. That is also an answer. That is also a choice there that you could write that as. Okay. All right. That is scale factor. Okay. Scale factor is just a scale copies. Scale factors are just smaller versions of bigger things. Okay, like a blueprint of a house, blueprint of a building, maybe even model trains, model cars, even model snakes. Okay, they are all scale copies, and they all have a scale factor. Okay, especially if you're redrawing it. All right, number 5. A frying pan has a diameter of 7 inches. Diameter, well, what's that tell you? We got circles. Yay, circles. What is the area to the nearest square inch of the smallest cover that will fit on top of the frying pan? So I got a circle here, okay? I wonder if I can put a circle. Oh, yes, I can. Heck yeah. Boom. Look at there. I love computers. Okay. So we got a frying pan with a diameter of 7 inches. So remember, diameter goes from edge to edge while passing through the center. Okay? That is going to be 7 inches. Now it's asking for a cover. Okay, I'm keep trying to fix this here, and it's just not working. It's asking for a cover. Now a cover, think of it like a top of a think of like a hat. Think of it like a a pot lid. I mean, so it's got to cover the top of it. Okay, that means it's going to cover all of this area inside the circle as well. Okay, so this is going to be an area problem. So A of a circle or area is going to be pi times radius squared. Okay, there. Pi times radius squared. Okay, so we got to figure out what our radius is for this in this case here. We know what pi is. Pi is 3.14. Okay, we know what radius is given the diameter. Diameter goes from side to side. It's a whole line segment. Okay, radius is half of that. So what's half of 7? Half of 7 is 3.5 squared. Okay, so you got. Okay, so we had 38. Okay, so we had area equals 38.465. Okay, so we get to this point here. A needs the nearest nearest square inch. Okay. Well, 38.4. Let's start with the 6 right here. That is going to make that 4 a 5. So it's going to become 38.5 square inches. Okay. So I need this to the nearest square inch. That 5 right here is going to pretty much, that's closest, given math rules, this is going to be close to 39 square inches. Okay, this will be your final answer. Okay, all right. So there's that. I'm going to have a new page here. All right. Oh my word, I'm getting aggravated. Okay, here we go. All right, so let's go to this one here. Okay, last one. Find the perimeter of the semicircular region. Round your answer to the nearest hundredth. Okay, well, this area here, I wonder if I ain't gonna try it. So this area it's only got a half circle. Well, we know the area of a whole circle, that's pi times radius squared. Okay. So A is pi times radius squared. Do you think what do you think we can do if we do half a circle? Well, what we could do is take all this right here and divide it by 2. This will be the area of a semicircle or a half circle. Okay. So I'm going to take you right back to it. The diameter appears to be 6 feet. Okay, appears to be 6 feet. So that means the radius is half of that. Okay, so diameter is 6 feet. So area, so just plug it in. Okay, replace pi with 3.14 times 3 squared, all divided by 2. Okay, so I'm going to be left with, okay, 3.14 times 9. 3.14 times 9. 3.14 times 9 is going to be equal to 28.26. Well, apparently right now room there. So I'll try to write that again. Okay, I'm going to have to write that below that. Okay. All right. So we got that all divided by 2. So we got 28.26 divided by 2. 28.26 divided by 2 is going to become 14.13, 14.3 over 1, or just 14.13. So the area is going to be 14.13 square feet. That last one there. All right, I apologize for the technical issues there. Please like this video, comment if you have any questions, subscribe to my channel. I understand we're not signed in, so I won't be signed in. And I hope you guys have a great week. I'll stay tuned. I'll post some more videos in the coming days. Okay, thank you.